Okay, good evening. Please, you are all welcome to today's class. It's another day. We thank God for life, and I'm sure you are really enjoying the class. I'm really grateful for your time, and I'm always happy to prepare and come and serve you as colleagues, um, masters and PhD students. All right. So today too, there's another section that we are going to have, another interesting area. It's a continuation of what we did on Tuesday. So without wasting much time, I'll first want to know if there's any issue concerning what we've done so far. Yes, if there's any issue, if there's anything you want to say, please, the floor is there. You can unmute and then um, say something. If there's any recommendations, you can say. If there's any applause or good messages to anybody, please, the floor is there for you to make it up. So let's give ourselves some few minutes. Let's say 2 to 3 as we wait for others to come. So far, I think we have 16 people. Normally we are 21, 22 thereabouts. So as we wait for some 1 or 2 minutes, please, the floor is open for you to make any comment or something. Thank you. Okay, it's like some people have sent some message in the message box. Emmanuel, all right. We appreciate your effort. All right. We thank God. Thank you for your dedication. Oh, and the impact. God bless you. Thank you so much. We thank God for life. It's getting tough. That's Yima Boating. But with you, oh, no, 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 with God. Okay. I'm just a vessel. All right. With God, we know we can get there, not me. All right. I'm just a vessel. Okay. Thank you very much. I think our time is up. So far, we are 16. We can proceed for today's class. Gifty, please, can we contact you if we should have any issue for future works? Because field is on us and okay, sure, sure. All right. Uh, okay. So I will post my QR code later on in the chat box so that if you scan, you can send me a request on WeChat. Thank you. All right. So, okay, our number is 16. I think it's almost 8:20. Our time is up. I think we can proceed and then see how best we can finish today's task. So realize that each and every day we are able to do some and it's each and every time we meet, we're able to do something new or something great. So please, you have to go back each and every time to start running the code. Either you run it or you go through the lines all the time so that you can become a chef, all right, in this area. It's very, very important. You try as much. I know we are all busy. Yes, school has almost most universities are reopened. And now the marathon is about to start. I'm also part, so let's try our best to because after these sections, or let's say after this training, if you leave the code behind and you don't practice, I will just leave you within a second. And the day you need it and you want to go for it, it will be a problem. So I will urge everybody to practice before the day we have class, and after that you continue to practice. All right. And I thank God so much. Ever since I got to know R, I've never stopped using it. I've been using it all this while. All right. So let's see where we ended. Then we'll come back to this page. All right. Let's see where we ended the other time. Not this one. Yes, this. Okay. So we started with this. Let me just run 1 or 2 so that although it's here, but I just want to rerun it. Okay. So we did with all this, and then we got some nice output. All right. Then we're able to get, so this was our final point. The actual and then the predicted. The actual. Okay, there's a question there. Oh, okay, Joanna, you're welcome. All right. So we have actual and then prediction. All right. So we realize that they are almost the same. It means our model is doing well. I think one of our colleagues did a good job. I think she had the close marking of the actuals and the prediction. That was the nice thing. Yes. So in fact, it was so interesting. All right. So now what are we to do? Now we've been able to know that the actual values and then the predicted values are close. All right. So it's time for us to study an important thing. That is what we call, how do we measure the importance of the model? When you talk about the model, we are talking about the regression models, the model that we have done. All right. How do we measure this importance, its importance? And also we know that the data set, okay, the data set has so many parameters. These are the parameters we are talking about. It has so many parameters. But the one that we have modeled is only with two parameters. It's only with two parameters. But we have so many parameters in the data sets. So the statisticians or data science, they realize that what about forming another model that will contain other parameters so that we can compare models with models. And if we are comparing models with models, what statistical tools can determine which model is doing very well? All right, which model is doing very well? So in this case, what we are going to do is that we are going to, first of all, learn how to measure the performance of a model. Is the model doing well or not? Then, how do we model how do we add on board other models which contains more parameters either than saying only two parameters? How can we add another parameter like a VS, like G, okay, like let's say displacement, like cylinder to the model so that we can now assess the models and then choose the best model. That is very, very important. So that is what basically we are going to do for today. Okay. All right. So we will now begin with what we call the measurement importance. Okay. So there's something we call the R square. All right. So let me take you back to the screen here. Um, okay. So we have what we call the model performance metrics. Model performance metrics. Now, with these model performance metrics, their duty is to calculate the predictive errors, all right, of the model, the entire model. So if you have, let's say, more than two models, even one model, all this, we can calculate the predictive errors in it, all right. So the first one we have is R square. R square, that's the very first one that we have. Then the second one we have is mean absolute error. Mean absolute error. Then we have root mean square error. Root mean square error. Then we have the residual square error. So these four metrics are very, very important. So if you're doing anything concerning model evaluation, then this should not be exempted. In fact, these are the tools that we use. All right. Okay. But when we talk about the R square, what are we talking about? Simply, R square, a statistical measure that indicates how well a model explains the variability of the target data. So in this case, the R square value that we are going to get should be between 0 and 1. it should be between 0 and 1. Okay. Or negative if the model fit poorly. When you get negative, it means that the model is not good at all. So discard the model. All right. But in normal sense, it should be between 0 and what? 1. Now, what the interpretation? The higher the value, or let's say closer to 1, the model explains greater proportion of the variation in the data set. Every data set has variations, all right? When you calculate the R square and it's approaching 1, when you say a number or a figure is approaching 1, it means that we have something like 0.5, 0.6, 0.8, 0.9. They are all approaching 1. So assuming I calculate the R square and I get 0.8, it means I'm not far from 1. So it means that the model is good. If I get 0.7, fair enough, it's like 70%. It means that 30% cannot be accounted for. If I get 0.6 as the R squared, if you change it to percentage, you have 60%. It means that the model can calculate or can explain 60% of the variability of the data. 40% it cannot account. So in this case, we would consider it as fair, but we want as much as possible closer to 1. 1 means 100%. That means the model is perfect, but we don't have perfect model. No. But what we want is at least between 75, that is 0.75 up to 0.95 or 0.99. All right. Okay. So in this case, the higher the value. So here is the clue here. The higher the value of the R square, the better the model. Now, when it comes to the root mean square error, with the root mean square error, okay, what it does is that it checks the predictive error. It's also another form of measure. It is very, very key. It's also another form of measure. Now, it ranges between 0 to infinity. It ranges between 0 to infinity. With this one, all right, the lower the value, the better. The lower the value, the better. So if it's approaching 0, it means that the error the predictive value is making is small and it is significant. Unlike the R square, the higher the value, the better. So there is some kind of oppositeness in this. All right. Okay. So that is about the root mean square error. Okay. With that, I can move to the next part. That is residual sum of squares error. The sum of squares difference between the actual and the predicted. So here is a kind of formula, all right, that we go through to compute. We're trying to explain the formula, but what we need to know is what we use it for model performance metrics, all right. Now here too, it is ranging between 0 to infinity. And here, the lower it is, the better. The lower the root sum of square residuals indicate a better fit used as part of the what other calculations like the R square. So here too, when it is too small means that it should be 0. But there's no way you can get an error to be 0. It means that when it's 0, it means that everything is perfect. No. So when it is approaching 0, then it means that the model is becoming good or is being good. But when it is moving away from 0, then we have a problem with the model. So when we come to comparison, we will compare each of these with the other models, then we do selection. So we'll get to a stage whereby we will have what we call model selection. All right. Now the last one, the mean absolute error. So here, it is also a difference between the absolute value and then the predicted. All right. The actual values and then the predicted. But we take the absolute form. All right. So if you take the difference and it is negative, you change it to positive. That's what you mean by absolute. Now with this one too, the range is between 0 and infinity. And this one too, the lower the value, the better the performance. The lower the value, the better the performance. So if you're comparing this to all the others, which one is the odd one?
R squared.
R squared. Thank you very much. All right. So with this, we can move to the board, the console. and then we can begin our running of codes. Great. So we are here. Now, always, okay, for since Tuesday, my machine have not gone off. Yes, because I'm doing a lot of work and stuff. So what it means is that my RStudio have not been closed. And what it also means is that all the running I have made previously is still in the mind of the of RStudio. So I can continue from here. But if you, by one means or the other, you've closed your machine, you've put it off and restarted it, the moment you open the RStudio, you have to start from a particular point where the data set is and run up to this side. If not, if you continue from here directly, you'll be getting some errors. All right. So for me, I will not start from the beginning. I can uh start from here. But I think when we started today's class, I went back. I just wanted to run one or two to see. Uh-huh. All right. So what I want to so here we are computing R squared. We are computing R squared. Now, as I said, we should bear in mind that this is to measure the model performance. That is the key word here. To measure the model performance. No, sorry. So we'll go through the manual process, and then before we can compute the R squared, we will need the following code. You didn't know to memorize it. I'll give it to you. So here we have SS total. So it is a formula work, all right, but you might not need it to, but it will give us the R squared, all right, value. So we have run this. Then we have our R squared value. So let me send you this on this one. Oh, don't worry, I'll give you. Okay. So you have it now. You can run it and check. All right. So please, what do you have? If you can put the value, okay, 0.8. You see, you is because your differences were too close. You are the one who had the best prediction leverage, so everything of yours will be correct. All right, thank you. I'm happy. Yes, yes, yes. So you see that yours is slightly different from Gifty's own. Uh-huh. All right. And then Gifty rather own is closer to even mine is even a little bit far away from his. All right. So Eugene, yours too is yours, and then that of Abe's own is close. Hey, Augustine. Mowley. Okay, 0.73. All right. Oh, Belinda. Uh who will sort Belinda out for me? Gifty, try and sort her out for me, okay?
Okay.
All right. Okay, thank you so much. So what does this R square mean? It means that now you can change this value to what percentage? You just multiply by 100. So you, for example, if I should take Joanna's own is 0.825. So let's say 83%. When a model is able to explain 82% of the variability, it means that the model is almost good. You see, it means that the model is almost good because 80 something. You imagine you get 82 in examination. How do you feel? At least you're not. All right. All right. So thank you. So it means that the model is good. So the rest, that is the 18% is unaccounted for it due to some other issues that we have to look for. That is later issue. All right. Thank you. Now we want to move on to the mean absolute error. The mean absolute error. So this is its computation. So we have this, you run, and then you get a value. Okay. So I'm posting it, and then you run it. Uh, okay. I think I've seen the code, right? So kindly check and run it, and then let's see your output. Okay, 2.4, 1.9, 2.4, 1.9. Okay, good. So what did we say about the mean absolute error? We said that the smaller it is, the better. You see? So it means we are approaching zero. For those getting 1.9, 1.9, approximately is 2. So you're not far from 2.4. And not far from 2.7. All right. So let's finish and see. Augustine, thank you. And who again? Yuma, thank you very much for running the codes. So let's look at the others. The root mean square. That one is the most powerful. Let me put it that way because of the square root in it. So the root mean square value is most preferred. Is most preferred, but all are important. We'll talk about each what it does in the model. So I'm sending it to you now. Uh, so please, you can run root mean square. Okay. All right. 2.5, 2.7, 2 point, very good. Thank you. So they are all small values. They are all small values. Okay, so please, if you have any question, you can ask.
Yes, please. You said they are all small values. To
Yes.
what standard? To what is
Oh,
the optimum?
it's
For the
zero.
R square is 100%.
Zero.
Okay, okay,
Zero. They
okay.
should be zero, actually, with the exception of the R square. All right. The rest should be zero. Okay. So as they
Okay.
approach zero, the better. But to get zero means perfection. Uh-huh. And it's impossible. All right. Okay. So if you are getting two, two is not far from zero. All right. Like the way we said that the 80 to 83% variability has been explained, that is for the R square, you're approaching exactly 100%, and that is good. Okay. So we want to put all this in table form so that we can have it at a go. All right. We want to put it in a table form so that we can have it at a go. So I'm going to run this code and then we see how the output look like. So yeah, Augustine.
Doc, please,
Yes.
you did not talk about p-value, or that's why we will not use p-value.
No, no, no. Here, p-value doesn't come in yet. All right.
Oh, okay. Okay.
Uh-huh.
Okay.
Yes. Okay. Okay. All right. So I'm running the code for actual prediction, the same data set. Then I have n, length of the actual, then parameter. Now, why is the parameter one? Why is the parameter one? The parameter is one because we are dealing with only one, what do you call it? A
It's
simple
one
linear
regret.
regression.
Yeah.
Yes, sure. All right. So thank you very much. So you have the calculation of the sum of squares. This one will lead us to the R square. This quote will lead us, but all is being put together. So I'm just showing the part. All right. So I'm just running them. Okay. So what the code will do is that it will not give you the answer straight away. It will all put it in table form for you. So that's why you are still seeing the color purple in that order. All right. So I'm just running them and then it put it in a table form for me. The metric and then the values. So I'm sending all these chunk codes. We call it chunk codes. All right. So it's not like an insult, but we call it chunk of codes. Starting from here and in there. Okay. So you can have it and then you print it out. Then we will now discuss. I'm saying that the metrics value you are getting here shows that the model is good because the errors are low, and then the R square is above 70%, which means that it explains most of the variability in the data set. The rest cannot be explained. But how do you know that this one is good when it is only one model? Because the parameter is only one. What about you have two parameters? You have three parameters. You have four. So when you have these parameters in that order, then you can now assess using this metric. Because each of the model will give you each metric value. Then you begin to compare. That's where the character of each model will come out, whether it's good or it's not good. So that's what we are to go there. We are to start now. So, all right. So we are considering two models first. Okay, just two models. So I'm going to consider this model. Now with this model, I have only one dependent. But with this one, I have two dependent. So I'll run the two. All right. I will not, I only make sure that it is correct. So when it is showing purple in this form, because it will show, I think, a different color, it means that everything is correct. All right. Okay. So let me give you this. So we are considering two models now. Now, once we have two models, we want to know which one is good. So I have predictive one. All right. Then I have model one here. Okay. So it means that I'm trying to deal with this. So it means that I'm trying to deal with model one. All right. Okay. So let me run this. Then I'll come to, let me take this one here so that to prevent confusion. And then I'll run this. Okay. So I have this. Then I'll move on to predictive two. Let me copy this same and put it here. Just that I will say predictive two. Then I'll change this one to model two. And then I will change this. So let me finish. I'll give it all. I'll change this one to this. I think I made an error somewhere. If not, you'll be confused. All right. Then I'll bring this one here. Okay. So you can see the difference now. So two parts. All right. So I'm now coming to run this. I think I don't need this one here. Just run that. This one. No. Um, predictive. No, sorry. Okay. So this is predictive two, predict model two, new data set, then the root mean square error two, then the actual. The actuals are all the same, but the prediction, it should be two. Okay, because it's for model two, then good. So if I should run this, all right. So now you compare the two values and then you can make your comment. We will say that this is an alternative way. So here, if I should run this, it's just a repetition. That's why I brought a line so that you know where this one is starting from. All right. When you run, it will give you for all of them. For all of them. So let me copy them for you. Hmm? It's too much. Please. The message box is saying that what I've copied is too much. So let me copy it in bits. So this is the first part. The second part. And the last part. I want to explain the entire thing here. All that I want to compute is this, because we already know what this means, but you want to understand the codes, each level. All right. Okay. So here is the model equation. All right. You model using one independent variable, so this is linear, this is multiple regression. Then you put the model here. Then you against new data set for prediction. So this is prediction. All right. Then you now come and print out the actual values that you are trying to predict here. You print out to stand alone from the data because it's for the two models. Now, this code is to compute regression, that's the R square, the mean absolute error. So this code is to compute all that. Okay. Now, what are the parameters? Uh, Let me see. This is 2 and 3. Number of predictors plus int. Now look at this side. Here, number of predictors for the first model is only one, right? Then the second one is only two. But when you come here, it's saying P is 2 rather, and P2 is 3. Why? Because anytime you have regression model, we have what you call the intercept. So when you add the intercept to it, it will increase to 2. Then here it will increase to 3. That's why we have. So you can see from here. All right. Then you inculcate it here, all right, into the metrics against the actuals. Okay. Then you say what? Comparison. R bind. R bind what? The model equals to model 1, and then the metrics. So the metrics that you put here, it means that this means that you are putting in a table form. This is the final table. All right. Okay. So that's why we learned something about the R bind. Combine them in row form. So this one is this, then this is this ones, and this metric is that. Okay, so then this is print, and you know print already. Print means let's see what is in comparison. All right. So on that note, Uh, oh, sure, sure. Problem solved. Problem solved. Great, 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 great. You must get it. You must get it. Please get an egg and eat right now and be free. All right. So what do we say? Let's compare starting from R square. Please, somebody should talk now. Yes, I'm not the only one here. Somebody should talk. Now you understand. I've given you the somebody
Model
should talk.
2, model 2 is good for R square
Why?
because of R square is higher than the other model 1.
Thank you very much.
Per
Thank
mile.
you. Thank you. You have solved that problem. Next, mean absolute error. Who will take that one?
Your model 2,
Who's the one talking now?
Mauli.
Mauli, you spoken already. Oh,
Yes.
no, no, no. I want somebody to talk. A different person, please.
Model 2.
Yeah, model two, yes. Model two,
Yes,
why?
because the value is lesser than that of model 1. It's closer to 0 than that
Exactly.
of model 1.
Okay, so the bottom line, thank you very much. All right, thank you. So the bottom line here is that apart from R square, which is supposed to go higher, the rest must go lower. You get the point. But when you check, in terms of R square, model one is higher. And in terms of the rest, in terms of R square, model two is higher. Sorry, is higher. And in terms of the rest, when I talk about the rest, I mean the mean absolute error, root mean square error, residual sum square error. Okay, the rest are lower. You can check. This side, they are all low. So it means that straight away model two is better than model one. And what goes into model two? Model two has two parameters. So it means that modeling this particular data set with two parameters is better than one parameter.
Does that
Modeling,
suggest that even with more or 3, 4, 5 would also is likely to be better than 2,
no, unless you've done it and you have gotten the
unless you
results.
test it?
Exactly. So we are going to go to three
Yeah.
now.
Okay.
Sure. So because sometimes when you add a third variable to make it three, two will still be better than three sometimes. Then it means that the other variable that you added didn't bring any meaningful information to the model
Model.
exactly.
Yeah.
So let's go to three models.
Okay.
All right, thank you. I hope you get the picture.
Yes.
Good. So let's go to three models. So I have three models. Okay, so let me run it here first. So in all case, it's good you start from scratch. All right. Okay. So I'm just going to run it. So this is the same. The interpretation is the same as the previous one. All right. The same function and then the same printout. All right. This one didn't print out. So let me copy this. Let me see. comparison. So I'll just say print. Print. Then I'll put comparison here. Then print this. Good. All right. So you run it and then we discuss. Oh, cannot take all. Okay. So let me send it in bits. First to up to here. Someone is done. All right, good. Great, 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 great. Nice results. Great. All right. So who will speak for us? Just one person to talk about this. Or
Yes.
you can, yes.
I'll do. So
All right.
in comparing the three models, I will still choose model 2. Why? Because it has the highest R square, and then the other three also the least,
The least.
approaching 0. Yes.
Good. That's all. So why not model 3? Because you have added additional parameter.
It means that the parameter added did not bring any anything significant
To the model, right?
to the model. Yes.
Exactly. That is all. That's the meaning.
Yeah.
Good. Thank you very much. All
You're
right. So
welcome.
that's all. So adding parameter doesn't mean that the model will become good, but just that you can try. Sometimes when you add, it means that it can be good based on the values you get. All right. So it means that model 2 is still better than. Now let's make it 4. Okay. Let's make it 4. Let's make it
Okay.
4. But before this, we can visualize this graph. I want us to visualize this. So I'll give you the code. So sometimes when it is becoming more, in terms of the models, is becoming more than 1, like more than 2, sorry, going to 3, 4, scanning through the models, the what they call R square and all that, the mean average error, the root mean square, scanning through to know which one is smaller, it becomes difficult. So we try to visualize it. Okay. We try to visualize it so that we can see it clearly. So to confirm what you said, we are going to visualize it. Now, you remember ggplot. Yes, I hope all you remember. What the full meaning of ggplot? Grammar of what? Graphics. All right. Okay, so I'm going to run this because I already installed it. So I'll just run the libraries. You run, and then you will see the plot. And then you see the plot. So let me copy this for you, and then you can run. Then you can all conclude on this. Okay, so you have it. If you don't run the library, you will not have it. I think reshape 2. If you don't have reshape 2, you can install. And now Joanna is an expert in installing packages. She's now the consultant. Joanna, I've not heard from you.
Please, I'm around.
I thought you've traveled back to Ghana for a wedding.
Very soon.
Okay. All right. So please make sure the reshape 2 is installed. All right. Okay. Yes, you have it. Good. If reshape is not installed, you can install it and then you can run it. Okay. Great. 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 So what can you see from the graph? You realize that the R square side, which one is the highest? They're almost at par, so you can't even see clear. The 0.778. They are at par. All right. But you look at the others, you realize that the very last one, the blue, the second model is low. The very last one, that's residual sum of squares error. All right. The blue, is it blue? Yeah, let's take it like that. Light blue or something. It's low. So it tells you that that is, and that one belongs to the model 2. So model 2 is doing very well than all of them. But with the mean average error, you realize that they're almost at par for model 2 and 3, and then root mean square error for model 2 and 3 almost at par. So the difference now is at the residual sum of squares error, and that brought the difference for the between the two, because so far it was only model 2 and 3 that was computing. After model 1 is out because the errors are higher, with the exception that the R square is lower. We don't want R square to be lower, R square to be higher. So that one is out. So the competition is between 2 and 3. I think the graph is clear. All right, good. So far, so good. Now, I want you to, when you go, your assignment, edit the code to include model 4. So I'm going to give you the beginning part of model 4, and then you will now try and edit the code to get, where should I start from? 4. Yes, 4 models. But I will start a way. I'll start in a way. I'll show you. Okay. I'll start and then okay, you let me show you. Let me. Okay. So model 4. So this is model 4. What is model 4 bringing on board? It has the weight, horsepower, display, and cylinders. You see, so cylinder has been added to it. All right. Cylinder has been added to it. Now let me go to this side. The very first one is okay for me. Let me come here. So let me pick this. Okay, and pick this one too. And pick this one. So I'm just, I'm picking this and this. Okay, let me pick everything here. So look at how I'm going to do the editing. Okay, so let me go up. After this is set. Now I need predictive 4. So I'll just copy one of them and say, okay, here, you should be 4. Then I'll come here, you two, you should be 4. For the data set, it should be the same, new data, test data set, that's new, all right? Now, for the actuals too is supposed to be the same. Now, parameters. If model 1 parameter is 2, model 2 parameter is 3, model 3 parameter is 4, then model 4 parameter will be what?
5.
This one, thank you. So, okay, so let me just, what I need is this one. Then put 5 here. Then I'll step down. For this side, you can write it later, okay? Where the hash keys continue, you can write it later. All right, now let's come here. With this side, you don't do anything. Here, the function to compute the matrix, you don't do anything. Yes, you leave it as it is. Then, with this side, you now have to include matrix 4. You now have to include matrix 4. So, 4, then actuals is the same. Then the predict is what? It's supposed to be 4. All right. Now look at this. This is 1, 2, 3, and this one is what? Is 4. Now here, the reason why it have reduced, you see that this is 1, but when you come here, it is 2. This include the intercept, but when you are here, exclude the intercept. So it means that each of them will reduce by 1. So we exclude the intercept. Okay. Now here, look at this side. Model 1, model 2, and model 3. So what do you think we should add to this? Model 4, right? So you just copy, just bring this copy. So interesting. All right. So just and edit this and say model 4. All right. Now the rest like this stays the same because each of them it will compute the R square for you. If you compute this, it will compute this. Now, no, I need to do something. Now look at this. When you come to the R square here, I have to do something. You see that this is R metric 1 for R2. So this is 2, 3. So I have to create another 1. So let me bring comma here and then copy this one. Please, it's a nice exercise. I don't know why I'm doing this, but pardon me, eh? All right. Then when you come to this side too, you have to move to the 4th level. So this is what I did to get to get everything right. All right, before coming. You know, and with this, anytime you get the code, you can edit so that it will give you the result that you needed. All right. So thank you for your attention. So I'm just creating the 4th section. Creating the 4th section. So this will be 4. And then the very last one. Don't forget to bring the comma first. Okay. Then change. If you don't change it, it will compute. So 4. All right. So now that I have this, let me go to the beginning portion and run. 1, 2, 3, 4. So normally my attention is on the 4th one. Yes, because that is the what I brought on board. There's a problem here. You see that I said P3, P3, P3. Here is supposed to be what? P4. Good. So let me run it again. So I can even start from here, running it afresh. Good. And then I can have this run, this. Results. Go. Should I copy mine for you or I should give you to do the editing? Should I copy mine for you or I should give you the 3 models so that you can add the 4th model to it?
Please give us the 3.
I should give you time, right?
The 3.
I should give you the 3. Yes.
Yes.
Okay. So the 3 you've already run it. So just go for it. Just recopy your 3. This one.
Oh, yeah. Yes,
So
please.
create a new section for it so that you don't confuse the 3 models with the 4th model you are doing. Yes, Belinda. Belinda, you can speak.
Yeah. Hello, Dr. Bernard.
Yes.
Sorry. Pardon me, I joined quite late, so I'm trying to catch up. But then when you got to the number of predictors,
Yes.
right? The P4, you didn't type the rest here. You left it the P4. Just
The P
concatenate 5 or something. There's no intercepts. You didn't put anything there. Why?
here.
The P4, sorry, the P4.
This
P4.
one.
Yeah. The next one.
This one.
Line 915. Yeah. Why
915.
didn't you
Oh no, I
continue?
said that when you can okay, you can just
Oh, okay.
because this one when it is muted, it is not part of the function. Okay, so the only thing
Okay.
here is you just add cylinder. I think the name is here. We call it a cylinder. This one. So you can just add this. So you can add it. All right.
Okay.
Good. All right. Thank you. So I've given you some small challenge. Edit it and see if you get the same results as mine. If you're able to get it, I don't know what should do for you. The room is quiet. Gifty is working. Somebody have sent a message. I don't, please, want Alewa. Okay, okay, okay. Oh, Alewa. Okay, all right. I think I will get you something more than that. I think I have to get you something more than that. More than Alewa. Mm.
Uh, Please, are we doing it right now or is it an assignment?
No, right now.
Hey,
Ah, that's why the room is quiet. I get your point, Mauli. Okay. You are saying Mode 4 is the best. I want others to finish.
Please, can I see your parameter cylinder? How you, because I think it's giving me error. Can I see yours?
Okay. Which part of the codes?
The cylinder,
The cylinder?
CY.
Yes, 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 yes. No, no, here. Here?
CYL.
Here.
It's CYL.
Yes, CYL.
Yes,
Yeah.
CYL.
Oh, okay. Thank you.
Hmm. Uh, you are still getting only 3 bars. Hey, Eugene.
Yeah, I'm still getting for only the model 1, 2, and 3. I don't know why.
It means that you didn't include it at this side. You didn't
I
check.
have.
You have
Wait, where? Let me see where you are saying I should include.
here. Create data frame. Did you work on this? Did you include these sections?
Create data frame. Create data frame.
Mm-hmm.
Uh, yeah, I have included it.
You have included it.
Yes, I have gotten the results with the models, but I'm talking about the plot. I'm not getting the 4 plots.
Oh, you've gotten the result, but you're not getting the plot. But we didn't edit the graph. No, you just bring it down here, copy from model
And
3, and then just run.
yeah,
Yes.
I don't know why it's not coming.
No, it should come because with this particular one, you don't edit because everything is incorporated into comparison. Joanna, I can see you are still not yet well. You have not recovered.
I'm loaded.
Come again.
I've sent mine already.
You sent it
Mine
to,
is
oh,
different.
okay. Hey,
Mine is different too.
okay. It's because of the splitting. Aye. Or maybe
Mm.
you use a different splitting technique, that's why. But the concept is more important, so it's okay.
I'm still not getting it. I don't know why.
Oh, no, no, no. For the visualization, we don't we did not what do you call it?
Yeah, I've not changed anything to, so I
Yes.
don't know why it's not coming.
So me too, I don't know what to say because I have used You're also getting 3
What?
bars.
I'm getting all the four, this one,
Models.
model. Yeah. But after it and I run the printing, I don't get the plotting, I don't get the 4 bars. I get only 3.
Mm. Mm.
I use it on a big screen.
Okay, yes, share with us, and I think this is the last thing we will do for today, so we are done. So let's okay, error in evaluating.
Please, this as you share.
No, wait. Gifty, thank you, You are correcting things. Now my new TA is Gifty. Okay, you can share.
Okay. So please, this is it.
Mm-hmm.
Let me run from here. So if I run this,
Mm-hmm.
I get
Mm-hmm.
the 4 models here, right? Now I've deleted this one, so I want to go and copy it and bring it back.
Mm-hmm.
The plots.
Don't
This is
copy
not,
the
the value is
comparison
not
there.
there.
No, don't copy from the copy from 646.
Yeah.
Mm-hmm.
Yeah, right.
Copy from that.
Yeah.
Yes. Now go down there. Mm-hmm. Run. Run.
I have. That's it here. This is the plot. Yeah, this is the plot. You see.
Open your this thing is too small. Open it. Open the space.
It's still 3. I don't think it's the space.
Ah,
See.
It's 4 now. You can see 4. These are 4.
Huh?
It's 4 now. When you extend it 4. 1,
When
2,
I
3, 4.
extend it's 4,
no, the
It's
columns.
4. 1,
If
2, 3,
each
4.
no no
The
no no
column is
each
1, 2, 3.
is supposed
Okay,
to
it's
be
a
it's
3.
3.
It's a 3. It's the 3. Okay.
okay. Close
You see
it.
the model 3, model
Yeah,
1,
yeah,
2,
yeah.
3.
Minimize it.
You're right.
Look. Hey, wait. This is where your problem is. Wait. Go to
Mm-hmm.
line 699. When you check only up to
I'm
model
coming.
3, add model 4.
699.
699. Go straight to the
Oh,
last
I did.
section. Good. You see?
I did. I don't know why it changed.
Maybe you were thinking about something. Mm.
No. Okay. It's like this.
You're supposed to make it, you see, you make it the model 3 2 times. So change it to 4.
Yeah. Thank you.
No, do it. Okay. It's
Yeah, it's
okay.
done. It's done. It has
Okay.
come.
All
Yeah.
right.
Thank you.
Okay. All right. Thank you very much. So, ladies and gentlemen, thank you for coming. This is the last section for today. Uh, let me see. Uh, yes, this is the last section for today. Now, your assignment, but not to be presented, just for your own. We have, look here. I would like you to follow what I'm showing you first. It's like I could see some people are still doing other things. All right. Now look at this. We have used this as a dependent, independent. No, this independent. And then we have used this 1, 2. Hey, Ali. Oh. And then we have used this 1, 2, but we have not used any of this. All right. We have not used any of this. Now, I would like to say something. This is just for practice. Create model 5. You add 1, that will be model 5. You add another one, model 6. You add another one, model 7. You add one, model 8. You add one, 9. Just try it and edit the code and do it. That is all. It's just for practice, but not to be presented. That is my assignment, not to be presented. So just for practice. That's all. If you agree, just let me know. Not to be presented, please. Just for practice. That's all. Thank you very much for coming for today's class.
Before you go, please, for the 4 models, which one do we say is the best?
Oh, okay. Now you notice
I
that,
think someone.
yeah, somebody said model 4. And I would like to explain. You notice that the R square is better from the graph.
But yes, but it doesn't hold for the others, the rest.
Yes, it doesn't hold for the others. So now we move to the mean absolute error. It is up with the model 4. But when you
Yes.
come to the root mean square error, it is down. That's the lowest.
Okay.
Then
And
when
it's
it
the
comes,
most powerful or most preferred, you said.
yes, but when you come to I've not finished though. When you come to the very last one, the residual sum of squares, it's high.
Yes.
Good. So R square is better. And then the, what do you call it? The root mean square error. So the most one is the root mean square error compared to the R
Square.
square. They are all showing good. So these two makes model 4 better than the others.
All better. Okay.
Yes. All right. Good. Okay. All right. So please, if you have any question, you can ask. If not, then we'll end for today. So how was today's class? Was it interesting or it was full of codes? Or it was full of that's
It
it's
was okay. With the final explanation you gave, looking at my results, I would still have to go for model 2.
You still have to go for model 2.
Yes, except if I've done a mistake somewhere, but looking at
Looking
with the
at yours.
explanations you gave, yes,
Yes.
looking at model 2
So
is
it
the
will
least
vary from
among all.
mine because of the sampling, right? All right. So for me, model 4 will be the best. Maybe yours models
Yeah.
will be because of the splitting. All right.
Yeah.
Yes. Somebody too wanted to speak.
Yeah. Dr. Bernard, it's me.
Okay.
Sorry, I have a general question about R. Anytime I shut down or I close R, when I come back, it's like my clothes and everything are gone. Like it's gone. I have to start again.
Come again.
Is there a way I can save them? I say anytime I close R or I shut down my laptop when I come back, it's like everything I've done on R is gone. Like the plots, they are all gone. I have to like run everything again. Is there a way I can skip this step and save everything?
Okay. I said that. Okay, let me explain your issue. But the codes here are not gone, right? The ones here, I'm highlighting the section.
No, they are.
So always, anytime you shut down
No, they are not
R,
gone.
what will leave is this side. This side will go. And even the graph side will also go. Okay. But this side will not leave. All right.
Yeah,
This side will not
it's
leave.
always there.
So what it means is that anytime you come back, try and start from the beginning to run the course like how I've been running. You run it to get the results you want to. All the time, try and start from the beginning. It's like a revision. before you can tackle
Okay.
anything you
Okay.
want to tackle. Yes. Uh-huh.
Okay.
All right. Good. And always make sure you
Okay.
save.
Thank
The
you.
saving button here. You make sure you save your code that
Yes,
you have.
thanks.
If not, you
Okay.
lose it. Thank you.
Okay.
Your
Bye.
question is a good question. All right. Any other? If there's no other questions, then Dr. Koko, please, your closing remarks for today. Okay, I'm sure she's not here. All right. So, ladies and gentlemen, we'll end here. Hopefully, next week we'll continue from where we ended. We'll look at more, and then we'll see why this is not good. There's a problem with this parameter metrics. There's another one we are going to use. So we'll get there. Hopefully, go over next week. So thank you, and grateful to be to lead this section. All right. So bye bye for now, everyone. Bye bye.
Okay, thank you.